Imagine standing under a blazing desert sun, and then, a split second later, warming your freezing hands by a roaring campfire in the snow. In both places, the intense heat hits your skin instantly. But how exactly do you feel that warmth so fast? The air sitting between you and the fire, or between you and the sun, hasn't actually had time to heat up yet. Conduction and convection simply aren't fast enough. Both of those standard heat transfer methods operate like a bucket brigade. They require physical matter, like air or water molecules, to physically bump into each other and pass the energy along. What you're actually feeling is thermal radiation. It's a type of electromagnetic wave, a synchronized oscillation of electric and magnetic fields that shoots through space at the exact same speed as light. This is the only form of heat transfer that completely ignores the bucket brigade. It needs zero physical contact and absolutely no physical matter to move energy from one place to another. Because this invisible energy bypasses matter entirely and constantly bombards us, human survival has long depended on figuring out how to block it, trap it, and control it. The first rule of this invisible system is that absolutely every object in the universe, including you, is constantly throwing off and receiving thermal radiation. And whenever these invisible waves strike a new object, a physical battle begins. The incoming energy faces one of two outcomes. It is either completely absorbed into the object, or it bounces off and is reflected away. The winner of that battle is largely determined by color. Dark surfaces are the ultimate thermal sponges, pulling in almost all the radiant energy that hits them. Observational, that is exactly why the exterior bottoms of heavy cooking pots and cast iron skillets are often intentionally blackened. The dark surface acts as a trap. It absorbs the maximum amount of thermal radiation from the fire, pulling it into the metal and efficiently converting it into conductive heat to cook the food inside. The dark color transforms the vessel into a precision-engineered component of the cooking process. We apply that exact same engineering to our basic everyday technology, the clothes on our backs. During the harsh, freezing months of winter, people naturally gravitate toward dark-colored coats, hats, and sweaters. Those dark fabrics are doing the exact same job as the cast iron pan. They actively soak up whatever scarce thermal radiation the winter sun offers, trapping that heat directly against your skin. But when the seasons flip and the sun beats down, we swap out the heavy dark layers for white or light-colored fabrics. Light colors act as wearable thermal shields. They maximize the reflection of the sun's intense radiation, pushing the heat away from the wearer. By simply changing the color of our second skin, we directly manipulate electromagnetic waves to survive extreme seasonal temperature shifts. One of the hardest everyday thermal challenges is keeping a liquid perfectly hot or ice cold in a hostile environment for hours on end. To do that, we rely on the thermos. Inside that metal shell is an invention called the Dewar flask. It is a double-walled vessel holding the liquid in an inner chamber, surrounded by an outer wall, with a deliberate, manufactured gap between them. That gap is an evacuated space, a literal vacuum. Because conduction and convection require matter to travel, stripping the air out stops those two forms of heat loss dead in their tracks. But there is still one major vulnerability. Thermal radiation doesn't need matter. It can effortlessly glide right through that empty vacuum and steal the heat from your coffee. Engineers solve this with a brilliant countermeasure. Both the inner and outer walls are coated with a highly reflective silver layer. When the radiant energy tries to escape, it hits that mirror finish and bounces right back into the hot liquid. The thermos succeeds because it creates a perfectly isolated thermal pocket, forcing an object's own radiant energy to reflect back onto itself. From our own bodies down on Earth to the most distant stars in the sky, the universe is locked in a constant, unending exchange of thermal radiation. Our primary methods for defending against or harnessing all that energy come down to mastering the simple physical balance of absorption and reflection. These principles serve as the structural logic behind our entire built environment. Even though thermal radiation is invisible to the human eye, its design logic is everywhere. It dictates what we wear, how we cook, and how we preserve our food in a universe built on heat.